Imagine for a moment something truly extraordinary, the entire history of our universe compressed into a single year. From that first infinitesimally hot, dense moment of creation, all the way to this very second as you're engaging with this fascinating journey through time. On this cosmic calendar, every month represents roughly 1 billion years of actual time, a scale so vast it challenges our human comprehension. Each day in our cosmic year accounts for about 40 million years of universal history. But here's something that will truly blow your mind. The entire story of human existence, from our earliest ancestors to our modern civilization, would occupy only the final seconds of December 31st. That's right, everything we've ever known, built, discovered, and achieved as a species fits into what amounts to a cosmic blink of an eye. This mind-bending perspective serves as our gateway into one of the most captivating stories ever told, the epic saga of our universe. Together, we're about to embark on an absolutely fascinating journey through cosmic time, tracing the evolution of everything we know from its most primordial state to the vast and mysterious realm we observe today. We'll witness how the cosmos transformed from an unimaginably dense point of pure energy into the expansive tapestry of galaxies, stars, and planets that now surrounds us. This isn't just any story, it's our origin story. The tale of how every atom in your body, every planet in our solar system, and every star in the night sky came to be. As we venture through this cosmic timeline, you'll discover how the universe has been constantly evolving, creating, and reshaping itself through processes so grand they defy ordinary human experience. From the first moments of the Big Bang to the complex cosmic web that exists today, we're about to uncover the remarkable series of events that made our existence possible. What makes this journey even more incredible is that we're not just passive observers of this cosmic drama, we're part of it. Every breath you take, every step you make, is part of this ongoing universal story that began billions of years ago. So settle in, open your mind, and prepare yourself for an extraordinary voyage through time and space as we explore how our universe transformed from its simplest beginnings into the rich, complex, and mysterious place we call home today. Approximately 14 billion years ago, an event occurred that would set in motion everything we know and everything we are. At this moment, the entire known universe, all the matter, energy, space, and even time itself was compressed into an infinitesimally small point, smaller than the smallest atomic particle we can conceive. This cosmic singularity was characterized by conditions so extreme they pushed the boundaries of human comprehension. The temperature within this point was staggering, over 1 quadrillion degrees, a heat so intense that even the most fundamental building blocks of matter couldn't exist in the forms we know today. To put this incomprehensible temperature into perspective, consider that the center of our sun, which we consider unimaginably hot, is only about 27 million degrees. The initial temperature of the Big Bang was billions of times hotter than that. This was a state of existence so different from our current universe that the laws of physics, as we understand them today, couldn't even function in the same way. Then, in a fraction of a second, so infinitesimal that our minds struggle to grasp its brevity, we're talking about a time span many times smaller than the time it takes for light to cross an atomic nucleus. This cosmic point underwent an explosive expansion of staggering proportions. This wasn't an explosion in the conventional sense, with debris flying outward into existing space. Instead, it was space itself that began to expand at speeds faster than light, a phenomenon we now call the Big Bang. This expansion wasn't just fast, it was rapid beyond imagination. In the first tiny fraction of a second, the universe underwent what cosmologists call cosmic inflation, expanding faster than the speed of light. This might seem to violate Einstein's laws, but it doesn't, because it wasn't matter moving through space, but rather space itself expanding. During this brief moment, our universe grew exponentially, laying the groundwork for the cosmic structure we observe today. The term Big Bang might suggest a chaotic explosion, but in reality, it was an incredibly ordered event, following precise physical laws that would eventually allow for the formation of everything we see around us. As the physicist Brian Greene once noted, it was less like a conventional explosion, and more like the universe suddenly switching on, transitioning from a state of incredible compression and heat to one of rapid expansion and gradual cooling. What makes this moment even more remarkable is that it represents not just the birth of our universe, but the birth of physical reality as we know it. Everything that exists today, every galaxy, every star, every planet, and every atom in your body, can trace its origins back to this singular moment in cosmic history. The Big Bang wasn't just the beginning of things in space. It was the beginning of space itself, marking the dawn of both time and physical existence as we understand them. This extraordinary moment continues to captivate scientists and thinkers worldwide, not just for its scale and importance, but because it represents the absolute limit of our current understanding of physics. Beyond this point, in the first fraction of a second, lies a realm where our current scientific models break down, hinting at even deeper mysteries about the nature of existence itself. When the legendary physicist Dr. Stephen Hawking described the first moments after the Big Bang as the most extraordinary event we have ever discovered in the universe, he wasn't merely engaging in poetic hyperbole. These initial moments were truly remarkable, representing a period of transformation so profound that it would establish the foundation for everything that exists today. In the immediate aftermath of the Big Bang, our universe was nothing like the structured cosmos we observe today. Instead, it existed as an inconceivably hot, dense plasma, a cosmic soup of fundamental particles swimming in a sea of pure energy. This primordial soup was so hot that even the most basic building blocks of matter as we know it couldn't maintain stable forms. The entire universe was a roiling inferno of quarks, leptons, and other fundamental particles, constantly colliding and interacting in a cosmic dance of creation and annihilation. During the first microseconds, as the universe expanded and began to cool, though still at temperatures that dwarf anything we can recreate in our most powerful particle accelerators, something remarkable happened. The fundamental forces of nature that we know today began to separate and take on their distinct characteristics. Gravity split away first, followed by the strong nuclear force, and then the weak nuclear force and electromagnetism. This separation of forces, known as symmetry breaking, was crucial for the future development of our universe. As the first second ticked by, the quark soup began to coalesce into more stable arrangements. These quarks, bound together by the strong nuclear force, formed the first protons and neutrons, the building blocks that would eventually make up the nuclei of every atom in existence. This process, called quark confinement, marked a crucial transition from the most primitive form of matter to something more recognizable to modern physics. In the span of the first 3 minutes, a time frame that seems incredibly brief on human scales, but was an eternity in terms of early universal evolution, these protons and neutrons began to come together through a process called nucleosynthesis. The universe was still incredibly hot, with temperatures in the billions of degrees, but it had cooled enough for these particles to start forming the first atomic nuclei, primarily those of hydrogen and helium. This period was so crucial that scientists often refer to it as the first 3 minutes, a time when the basic building blocks of matter were forged in the cosmic furnace. The ratio of hydrogen to helium created during these 3 minutes would determine the composition of the first stars and subsequently the entire chemical evolution of the universe. What makes these moments particularly fascinating is that they represent conditions we can never fully recreate on Earth. While our most powerful particle accelerators can give us glimpses of these conditions, they can only approximate the incredible energies and densities that existed in these first moments. Yet through careful observation, mathematical modeling, and theoretical work, scientists have been able to piece together this remarkable story with increasing precision. The legacy of these first moments continues to influence our universe today. The proportion of elements created, the distribution of matter, and even the large-scale structure of the cosmos were all determined in these crucial opening minutes of cosmic history. When we look up at the night sky, we're observing the end result of processes set in motion during these extraordinary first moments, truly making them, as Hawking noted, the most remarkable event we've ever discovered. Around 300,000 years after the Big Bang, a pivotal moment occurred in the evolution of our universe, an event so significant that astronomers call it the recombination. As the cosmos continued its relentless expansion, the temperature finally dropped to roughly 3,000 degrees Kelvin, marking a crucial threshold. At this temperature, something remarkable happened. For the first time in cosmic history, electrons could successfully combine with atomic nuclei to form the first complete atoms, primarily hydrogen and helium. This moment was revolutionary for more than just the formation of atoms. Prior to this, the universe was opaque, filled with a dense fog of free electrons that scattered light in all directions, much like car headlights in thick fog. These free electrons acted as a cosmic barrier, constantly interacting with photons, particles of light, and preventing them from traveling freely through space. But as electrons began combining with nuclei to form complete atoms, this fog began to lift. The transformation was dramatic. Suddenly, photons that had been trapped in this cosmic fog were free to travel unimpeded through space for the first time. This release of light is still visible today as the cosmic microwave background radiation, essentially the afterglow of the Big Bang itself, and one of our most important windows into the early universe. Scientists often refer to this moment as the time when the universe became transparent. However, this transparency ushered in what we now call the cosmic dark ages. Despite the universe becoming transparent, there were no sources of new light yet, no stars, no galaxies, just vast clouds of hydrogen and helium atoms floating in the dark void of space. This darkness would persist for hundreds of millions of years as gravity slowly worked to pull these atomic clouds together. This era is particularly intriguing to astronomers and cosmologists because it represents a crucial transition period. The universe was no longer too hot and dense to study with conventional physics, but it hadn't yet developed the complex structures we see today. It was during this time that the stage was being set for the first stars and galaxies. As tiny variations in the density of matter, quantum fluctuations that had been frozen into place during the universe's earliest moments, began to grow under the influence of gravity. The Dark Ages might seem uneventful compared to the drama of the Big Bang or the later formation of stars and galaxies, but this period was essential for the universe we know today. It was during this time that matter began to clump together under the influence of gravity, forming the seeds that would eventually grow into the first stars. The duration and conditions of the Dark Ages played a crucial role in determining how galaxies would eventually form and cluster together, shaping the large-scale structure of the universe we observe today. Studying this period remains one of the greatest challenges in modern cosmology precisely because it was dark. Without any sources of light, astronomers must use indirect methods to understand what was happening during this crucial phase of cosmic evolution. Yet understanding the Dark Ages is vital to completing our picture of how the universe transformed from its simple beginnings into the complex cosmos we see today. This profound transition from an opaque universe to a transparent one, followed by an era of darkness, set the stage for everything that would follow. The first stars, the first galaxies, and eventually the rich cosmic tapestry we observe in our night sky. It's a reminder that even in apparent darkness, the foundations for great things were being laid, one atom at a time. If you are as amazed as I am by this epic story of our universe, how about leaving a like? This helps us a lot to keep telling these incredible stories. After approximately 200 million years of darkness, the universe witnessed one of its most dramatic transformations, the birth of the first stars. This moment, often called cosmic dawn, marked the end of the Dark Ages and the beginning of a new era in cosmic evolution. As Dr. Jane Liu of MIT so eloquently compared it, this moment was like switching on the lights in a dark room, suddenly revealing everything that had been present but invisible in the darkness. These first stars, known to astronomers as population 3 stars, were unlike anything we see in the universe today. They formed from pristine clouds of hydrogen and helium, the only elements available at that time, and they were true cosmic giants. Most of these stellar pioneers were likely hundreds of times more massive than our Sun, and due to their immense size and pure composition, they burned hotter, brighter, and far more briefly than modern stars. The process of their formation was remarkable. Over millions of years, gravity had been quietly at work, pulling together vast clouds of primordial gas into increasingly dense clumps. When these clouds reached a critical density, their cores became hot enough to trigger nuclear fusion, the process that powers all stars. As these first nuclear fires ignited, they pierced the cosmic darkness with brilliant ultraviolet light, more intense than any stellar light we see today. These first stars were not just bright, they were transformative. Their intense radiation began to change the very nature of the surrounding universe. Their powerful ultraviolet light started to break apart nearby hydrogen atoms in a process called rionization, creating bubbles of ionized gas that gradually expanded and merged. This process would eventually transform the entire universe, making it more transparent to certain types of radiation and setting the stage for the cosmic structures we see today. But perhaps most importantly, these first stars were cosmic alchemists. In their incredibly hot cores, they began the process of stellar nucleosynthesis, creating heavier elements like carbon, nitrogen, oxygen, and iron for the first time in the history of the universe. When these massive stars ended their brief lives in spectacular supernovae explosions, they scattered these newly forged elements into space, enriching the cosmic environment and making possible the eventual formation of planets, complex molecules, and ultimately life itself. The light from these first stars also began to illuminate the cosmic web, the vast network of dark matter and gas that had been invisibly shaping the universe's structure during the Dark Ages. As Dr. Liu's analogy suggests, their light revealed the underlying architecture of the cosmos that had been developing in darkness. We could finally see the large-scale structure of the universe taking shape. This era of the first stars was relatively brief in cosmic terms, but its impact was profound and lasting. These stellar pioneers set in motion processes that would define the evolution of the universe for billions of years to come. They began the enrichment of the cosmic environment with heavy elements, triggered the rionization of the universe, and provided the energy and material for the formation of the first galaxies. Today, none of these first stars remain. They all burned out billions of years ago. However, their legacy lives on in every atom of carbon in our bodies, every breath of oxygen we take, and every iron atom in our blood. When we look up at the night sky, we're seeing generations of stars that followed these first pioneers. But it was these original stellar beacons that first brought light to the darkness and began the process of creating the complex cosmic environment we inhabit today. The birth of the first stars truly represents one of the most important transitions in cosmic history, the moment when the universe first began to shine with its own light, setting the stage for all the stellar and galactic evolution that would follow. It was, in a very real sense, the universe's first dawn. As the first stars illuminated the cosmos, the universe was poised for its next great transformation, the formation of galaxies. Through the relentless force of gravity, these early stars began to cluster together, creating ever larger stellar communities that would eventually become the first galaxies. This process wasn't simply a matter of stars drifting together. It was an intricate cosmic dance orchestrated by the invisible hand of dark matter. The formation of galaxies marked a crucial step in cosmic organization. Dark matter, which had been present since the earliest moments of the universe, created vast gravitational wells, cosmic frameworks that would become the scaffolding for galaxy formation. Within these dark matter halos, gas began to collapse and concentrate, leading to burst after burst of star formation. These stellar nurseries became more numerous and more closely packed, giving birth to the first galactic structures. These early galaxies were wildly different from the majestic spiral and elliptical galaxies we see today. They were smaller, more irregular, and far more active in terms of star formation. They were cosmic crucibles, forging new elements in their stars and enriching their environments with each successive generation of stellar birth, life, and death. Through countless collisions and mergers, these primitive galaxies grew larger and more complex, gradually evolving into the diverse array of galactic forms we observe in our modern universe. Our own cosmic home, the Milky Way, began its journey approximately 12 billion years ago. Its formation story is a testament to the dynamic nature of galactic evolution, a process that continues to this very day. The Milky Way started as a collection of smaller protogalaxies that gradually merged together under the influence of gravity. Each collision brought new stars, gas, and dust into our growing galaxy, while also triggering waves of new star formation. This process of galactic assembly wasn't peaceful or orderly. It was marked by dramatic collisions and interactions, each leaving its mark on our galaxy's structure. The evidence of this violent past can still be seen today in the form of stellar streams, ribbons of stars that were once part of smaller galaxies torn apart by the Milky Way's gravitational forces. These cosmic fossils tell the story of our galaxy's growth through countless mergers and acquisitions. As our galaxy evolved, it developed its characteristic spiral structure, a vast pinwheel of stars, gas, and dust spanning roughly 100,000 light-years in diameter. Our Sun and its planetary system reside in one of these spiral arms, about 26,000 light-years from the galactic center. This spiral structure isn't static. It's a dynamic pattern that rotates and evolves, with the spiral arms acting as cosmic traffic jams where gas accumulates and new stars are born. The Milky Way continues its evolution even now. It's currently in the process of cannibalizing several smaller satellite galaxies, including the Sagittarius dwarf galaxy. Moreover, we're on a collision course with our nearest large galactic neighbor, the Andromeda Galaxy, which will meet in approximately 4.5 billion years. This future merger will transform both galaxies into a single, massive, elliptical galaxy, a cosmic dance that demonstrates how galaxy evolution continues billions of years after the first galaxies formed. What makes this story even more remarkable is that we now understand galaxies aren't isolated islands in space. They're connected by vast cosmic webs of dark matter and gas, forming an even larger cosmic structure that astronomers call the cosmic web. This interconnected network of galaxies, clusters, and superclusters represents the largest known structures in the universe, showcasing how the simple gravitational clumping of matter that began with the first stars has led to ever more complex and larger-scale cosmic organizations. The story of galaxy formation is ongoing, a testament to the dynamic and ever-evolving nature of our universe. Each galaxy, including our Milky Way, represents a chapter in this continuing cosmic story, where gravity, dark matter and the complex physics of star formation work together to create the magnificent cosmic structures we observe in our night sky. Approximately 6 billion years ago, in one of the spiral arms of our Milky Way galaxy, specifically in what we now call the Orion Arm, an extraordinary chapter in cosmic history began to unfold. A vast cloud of gas and dust, enriched by the remnants of previous generations of stars, began to collapse under its own gravitational pull. At the center of this collapsing nebula, a new star was being born, our Sun. This stellar birth wasn't a simple matter of gravitational collapse. As the cloud contracted, it began to spin faster, much like an ice skater pulling in their arms during a spin. This increasing rotation caused the cloud to flatten into a disk, the protoplanetary disk, that would eventually give birth to our entire solar system. At the center of this disk, temperatures and pressures rose dramatically until nuclear fusion ignited, and our Sun burst into life. The birth of the Sun marked only the beginning of our solar system story. The remaining material in the protoplanetary disk began an elaborate dance of creation. In the inner regions of the disk, where temperatures were highest, only materials with high melting points could survive as solid particles. This explains why the inner planets, Mercury, Venus, Earth, and Mars, are rocky, composed primarily of metals and silicates that could withstand the intense heat near the young Sun. Further out in the disk, beyond what we now call the frost line, temperatures were cool enough for volatile materials like water, methane, and ammonia to freeze into solid ice. This fundamental difference in temperature and composition would ultimately lead to the formation of the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. The process of planet formation itself was a remarkable demonstration of cosmic construction. It began with tiny particles of dust, some no larger than grains of sand, colliding and sticking together due to electrostatic forces. These small clumps gradually grew larger through countless collisions, eventually forming planetesimals, bodies large enough for gravity to begin playing a significant role in their further growth. As these planetesimals grew, their increasing gravitational pull allowed them to attract more material, leading to a period of runaway growth. The largest bodies grew the fastest, eventually becoming planetary embryos. This process wasn't peaceful. It was marked by violent collisions that could either lead to growth or destruction. One such collision between a Mars-sized body and the early Earth is thought to have led to the formation of our Moon. Our own planet Earth formed through this process of accretion and collision. Its initial composition was very different from what we know today. The early Earth was a hot, molten world, bombarded constantly by debris left over from the solar system's formation. This period of intense bombardment helped deliver water and organic compounds to our planet, setting the stage for the eventual emergence of life. The formation of the giant planets, particularly Jupiter and Saturn, played a crucial role in shaping our solar system. Their immense gravitational influence helped clear their orbital regions of debris, while also affecting the distribution of smaller bodies throughout the solar system. Their formation and migration may have been responsible for the late heavy bombardment period that occurred about 4 billion years ago, when many of the craters we see on the Moon and other bodies were formed. What makes our solar system particularly fascinating is that we're now discovering it might be somewhat unusual compared to other planetary systems we've observed. The neat, nearly circular orbits of our planets and their ordered arrangement, rocky worlds inside, gas giants outside, isn't necessarily the norm. This realization has made us appreciate even more the precise set of conditions that led to our cosmic home's formation. The story of our solar system's birth continues to be refined as we gather new evidence from space missions, meteorites, and observations of other star systems forming today. Each new discovery helps us better understand the incredible sequence of events that led to the creation of our cosmic neighborhood and ultimately to our very existence on this pale blue dot we call Earth. This cosmic birth story reminds us that we are intimately connected to the stars, not just poetically, but literally. Every atom in our bodies, heavier than hydrogen and helium, was forged in previous generations of stars, making us, in a very real sense, children of the cosmos. The universe we observe today is almost incomprehensibly vast. Current estimates suggest that our observable universe contains more than 2 trillion galaxies, a number so large it challenges our ability to truly grasp its magnitude. To put this in perspective, if you could count one galaxy per second without stopping, it would take you over 63,000 years to count them all, and this is just what we can observe from our vantage point on Earth. Each of these galaxies is a cosmic metropolis in its own right, containing anywhere from millions to trillions of stars. Our own galaxy, the Milky Way, is considered relatively average, with its estimated 400 billion stars. When we multiply this by the number of galaxies, we reach a figure for the total number of stars in the observable universe that exceeds the number of grains of sand on all of Earth's beaches, somewhere in the region of septillions. That's a number followed by 24 zeros. But the modern universe is far more than just stars and galaxies. We now know that what we can see, all the stars, planets, gas and dust, makes up only about 5% of the universe's content. The remaining 95% consists of 2 mysterious components: dark matter, about 27%, and dark energy, about 68%. Dark matter, while invisible, makes its presence known through its gravitational effects on visible matter, helping to shape the large-scale structure of the universe. Dark energy, even more mysterious, appears to be driving the accelerating expansion of the universe, pushing galaxies apart at an ever-increasing rate. The structure of today's universe resembles a cosmic web, with galaxies and galaxy clusters arranged along filaments of dark matter separated by vast voids. These voids are not truly empty, but contain extremely rarefied gas at temperatures of millions of degrees. The largest known structures in the universe, called superclusters, can span hundreds of millions of light-years. The modern universe is also remarkably dynamic. Stars continue to form and die, galaxies collide and merge, and black holes devour surrounding matter while shooting out powerful jets of energy. We observe cosmic explosions called gamma-ray bursts that can briefly outshine entire galaxies, and we detect gravitational waves from colliding black holes and neutron stars, rippling through the fabric of space-time itself. Meanwhile, the universe continues to expand. Recent observations suggest this expansion is accelerating, driven by dark energy, leading to an ever larger cosmos. Galaxies that are sufficiently far from us are receding faster than the speed of light due to the expansion of space itself, meaning there are regions of the universe we will never be able to see or reach, no matter how long we wait or how fast our spacecraft might become. Temperature-wise, the modern universe has cooled considerably since its hot beginning. The average temperature of space, as measured by the cosmic microwave background radiation, is now just 2.7 degrees above absolute zero. However, this average masks enormous temperature variations, from the ultra-cold of deep space to the billions of degrees found in the cores of stars and around black holes. This modern universe, with its complex structures and mysterious components, represents the current state of a 13.8 billion-year evolutionary process that began with the Big Bang. Every atom, every star, every galaxy we see today is the product of this lengthy cosmic evolution. And the process continues. The universe we observe today is just a snapshot in an ongoing story of cosmic evolution, a story that will continue to unfold for billions of years to come. Perhaps most remarkably, this vast cosmic arena has produced, at least in one tiny corner, beings capable of comprehending and studying it, us. Through our observations and scientific endeavors, we've been able to piece together this incredible cosmic story, from the first moments of the Big Bang to the rich tapestry of the modern universe. As we continue to explore and discover, our understanding of this magnificent cosmos continues to grow, revealing new wonders and mysteries that await our investigation. From an infinitesimally small point to the vast and mysterious cosmos we observe today, this is our story, the epic tale of the universe. What makes it even more extraordinary is that this cosmic narrative continues to unfold with each passing second, writing new chapters in the greatest story ever told. The universe we observe today is not a static tableau, but a dynamic, ever-evolving masterpiece of cosmic proportions. When we contemplate our place in this grand cosmic drama, we discover something truly remarkable. We are, quite literally, children of the stars. Every atom in your body, the calcium in your bones, the iron in your blood, the carbon that forms the basis of life itself, was forged in the heart of a star that exploded billions of years ago. These stellar furnaces, through their life cycles and dramatic deaths, created the building blocks that would eventually come together to form everything we see around us, including ourselves. We are not merely observers of the cosmic story. We are made from its very essence. This profound connection to the cosmos gives us a unique perspective on our existence. When you look up at the night sky, you're not just gazing at distant points of light. You're looking at your cosmic ancestors, the stellar formations that made your existence possible. The atoms in your body have existed for billions of years, recycled through countless cosmic processes, from the first generation of stars to the formation of our solar system, and ultimately to you. The story of the universe is also a story of discovery and wonder. With each new technological advancement, each new observation, and each new theoretical breakthrough, we peel back another layer of cosmic mystery. Yet wonderfully, each answer we find seems to lead to even more intriguing questions. The universe remains as fascinating and mysterious today as it was when our ancestors first looked up at the night sky in wonder. As we continue our journey of cosmic exploration, we invite you to join us in this magnificent quest for understanding. The mysteries of dark matter and dark energy await our investigation. The questions of how the first stars formed, how galaxies evolved, and whether we are alone in this vast cosmos still beckon. Every day brings new discoveries, new insights, and new questions to ponder. By subscribing to Exploring the Universe, you become part of a community of cosmic explorers, united in our curiosity about the deepest mysteries of existence. Together, we'll venture into the unknown, examining everything from the quantum realm to the largest structures in the observable universe. We'll investigate the birth of stars, the death of galaxies, the nature of black holes, and the possibility of life elsewhere in the cosmos. Remember, every time you learn something new about the universe, you're learning about your own cosmic heritage. We are the universe becoming aware of itself, and through our collective curiosity and exploration, we continue to uncover the profound secrets of our cosmic home. Join us on this extraordinary journey as we explore the deepest mysteries of the universe, our universe together. Let's embrace our role as cosmic explorers and continue this magnificent journey of discovery. The greatest story ever told is still being written, and you are part of it. Welcome to the cosmic adventure.